So let's talk about the binomial theorem. So first thing we want to do is talk about Pascal's triangle. You guys may or may not have seen Pascal's triangle. Um, just a real quick in chat. Have you seen this before, Pascal's triangle before or not? Just yes or no, right? Well, I got a whole bunch of yeses. Okay, so most people know how it works. I haven't seen a single no yet. You know, you just add up these two numbers, you get this number. You add up those two numbers, you get this number. You add up those two numbers, you get this number, and just so forth and so forth. Yeah, yeah, yeah. And then technically here there's a zero here, and so everywhere you don't see numbers, technically you have zeros, and the zeros add up to be zeros technically. All right, so let's just write out two more just for those. So here, if I was going to write out the next line, it'd be 1, um, 7, 6 and 5 would be 21. This would be 35. This would be 35. This would be 21, and then it repeats itself. So it'll just repeat. And then here, oops, and let's do n equals 8. So our eighth row here will have 1. Add that up, I'll get 8. I'll add this up, and I'll get 28. Add this up, I'll get 56. Yeah, 56. 70, and then the numbers repeat 56, 28, 8, and 1. Okay. All right, so now we're going to do something really kind of long and boring. And this is just, and I think by doing it the long way once, it helps you to see why what happens, right? All right, so if n equals 1, we have 1 a to the b times n, which is just a plus b. Not very interesting. N equals 2, so we have a plus b squared. So this is equal to a plus b, a plus b. Now here, if I do FOIL this, I'll get a squared plus 2ab plus b squared. All right, so let's do something a little bit more interesting. N equal to 3. So you guys know how to do this, but here if I have n equal to 3, I have ab cubed, which is equal to ab times a plus b squared. Now, why would I write it that way? I know what a plus b squared is, right? In fact, I'm not even going to write it that way. I'm going to write as a squared plus 2ab plus b squared. I'm going to write that out. So a times all this will be a cubed plus 2a squared b plus ab. B times all this, I'm going to write below it, but I'm going to stagger it over by 1. And it's going to make sense why I'm going to do it that way. So this becomes uh, a squared b plus um, 2ab squared plus b cubed. Now, by staggering it over by 1, I make this real easy on me, right? I can just add straight down. So I have a cubed plus 3 a squared b plus 3ab squared plus b cubed. Okay, so that's just an easy way of doing it. We're going to do this one more time. And to the fourth. So we're going to have a plus b to the fourth equals a plus b times this mess, right? And I'm just going to save you time, save me time. Put that there, right? So a times this will be a to the fourth plus 3a cubed plus 3a squared b squared plus a b3. And then if I have b times this, same as before, I'm going to move it all over by 1. And so I'll have a cubed b plus 3a squared b squared plus 3ab cubed plus b to the fourth. Add that all up, I'll get a to the fourth plus plus 4ab, or 4 cubed ab plus 6a squared b squared plus 3a, or plus 4ab cubed plus b to the fourth. All right. So from here, we can see some general guidelines, right? So as I go up, what happens here is I just start with a to the fourth, and then I slowly move one power over to the b. So I'll have a to the fourth, and I'll have a cubed b, and then I'll move another power over to b, so a squared b squared, move another power to b, so a b cubed, and move another power to b, so it's just all in b. So a to the 0, or just b to the fourth. And where are my coefficients? Well, my coefficients just come right from here, right? And now why does that happen? Because of the staggering, right? Because of the staggering, I get the same coefficients here. So here are the coefficients for this. Here I have 1, 3, 3, 1. That's the same here as 1, 3, 3, 1. And so here I have a to the fourth, so that'd be 1, 4, 6, 4, 1 for my coefficients. Here for a equal to 1, I have 1 and 1, right? Here for n equal 2, I have 1, 2, 1. And so this, if I'm expanding any binomial by any power, I'm just going to always have this, right? Yeah, blast from the past. Yeah, it definitely is. Some of you may be 100% fluent in doing this already. Some of you may not be. So I'm going to still teach it as if it was new. Okay, I'm going to give you guys a second to write that down. All right, so let's show you how to do this in general. All right, so in general, let's go to it. Boop. Thank you. So in general, if I'm expanding some polynomial a to b to the n, a plus b to the n, there are going to be n plus 1 terms. So the first one being a to the n, and the second one being, I need a little space here, b to the n, right? The exponents of a decrease by 1 as you go, and b goes up by 1 as you move across from the terms, right? The exponents of a and b always add up to n, and the coefficients come from the nth row of the Pascal triangle. So let's do to the 7th. So we don't need to go all the way through it, but let's just wander through it. So here, we're going to have, let's just go ahead and write a to the 7th plus some blank. I'll come back to the blank. And then it'll be a to the 6th. So this goes down by 1, b goes up by 1, plus some blank. A to the 5th, b squared, plus some. Let me leave my blanks in more strategic spots. I'm going to rewrite this just so I'm going to leave blank, and then I'm going to hit a 6b, and then the plus right after that, blank. A to the 5th, b squared, plus blank. A to the, so this goes down 1, this goes up 1, so this would be 4, b third, plus, leave myself a spot, a to the 3rd, b to the 4th, plus, leave some spot, a to the squared, b to the 5th. I'm going to just go down to the next line so I know I have enough room. So I'll be plus some empty thing, a, b to the 6th, plus something, b to the 7th. So as we go across, this goes down by 1. So a goes up, down by 1, b goes up by 1. A goes down by 1, b goes up by 1. Where do we get our solutions? Well, here. The 1, 7, 21, 35, 35, 21, 7, 1. So it'll be 1, 7, 21, 35, 35, 21, 7, and then 1. So I guess I didn't need that way over there. I could put it over here. Okay. And so we just expanded a to the 7th. Now, what happens if it looks a little bit more interesting like this? So here's something that looks a teeny bit more interesting. Because this is, in real life, what you're going to get. You're going to get something a little bit more like this. So what we're going to do here is we're going to have 2 So this is going to be my A, this is going to be my B, right? So I'm going to let A equal to 2x and B equal to 3y, just in this case. So I'll have 2x to the fourth power plus 4, which is my coefficient, of 2x to the third power, 3y to the first power, plus 6, which is my coefficient here, 2x squared, 3y squared, plus 4, which is my coefficient from my Pascal triangle, 2x, 3y cubed, plus 1 of 3y to the fourth. All right, now we just crunch through the numbers. So 2 to the fourth power is 16, x to the fourth, plus 4 times 8 times 3 is 96, x cubed y, plus 6 times 4 times 9, 4 times 9 is, oh, how do I want to do this? Let's do 9 times, that would be 36. 36 times, hold on. All right, so I'm not calculating this. Our brain just is not computing it. That's why we have Wolfram Alpha. Hi, Wolfram Alpha. La, da, 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 da. I'll show you how to do this in Wolfram Alpha. Hello, yeah, go ahead and leave page. And so here I'm just going to have 2x plus 3y to the 7. And then you're just going to hit the word expand. Oops, I'm not doing it that big. Here we go. Aha. Okay. So the number here is 216. I guess I could have done that in my head. 9 times 6 should have given me 54. 54 times 4 would have given, yeah, 216, right? All right, so 216 x squared y squared. This is 8 times 27. 8 times 27 is 216. X cubed, and then 3 to the fourth is 81. Y squared, or y to the fourth. Okay. Yeah, thanks. It was a 4, not a 7. All right, let's do this one more time. All right, so let's do this for this. And so here we're going to say A is equal to 2 and B is equal to minus 3x. And make sure that you carry in the negative when you do this, okay? So make sure you carry in that negative. So here we're going to have 2 to the fifth plus 5, which would be our coefficient, times 2 to the fourth negative 3x to the first plus, what's my coefficient? 10, 10, 5, and 1. Okay, that makes it easy. 10 times 2 to the third, negative 3x squared, plus 10 times 2 to the squared, minus 3x cubed. And notice here that the powers here, 2 and 3, 2 and 3 add up to 5, plus 5 of 2 times negative 3x to the fourth plus negative 3x to the fifth. And let's crunch through those numbers. So 2 is 32. This becomes minus 240. This one I already pre-written. This becomes plus, this is 9 times 8, which is 72 times 10. 72 is 70. Here I have an odd number of evens. Here I have an even number of negatives, right? Here I'll have an odd again. And so usually if one of these is odd, I'll switch from positive to negative, positive. So this one will be negative 8 1080, and then it becomes positive 10. These numbers get large. They do. And then minus 3 to the 300, 430. Okay. All right. So let's talk about factorial. And so if when a mathematician sees 10, you know, I got 100 with an exclamation point on it. It's like, oh man, they got a lot, right? Because to mathematician, the little factorial symbol or explanation means 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 onward up until n, right? So 4 factorial will be 1 times 2 times 3 times 4. But 100 factorial, so, when someone's like, I got 100, right? Math, in English, that makes a lot of sense. In math, let's just figure out what that number is. Yahoo, that's 100 factorial, right? It's not a small number. It's just not. um, and so factorials tend to grow very, very quickly. Um, so, yeah. And so this is what a factorial is. Have you guys seen factorial before? Yes or no? Just out of curiosity. Do you mess with this? Some people, yes. Some people, no. Okay. So factorial is, so if I do 4 factorial, let's do a couple simple ones. So let's do 5 factorial real quick. So 5 factorial is equal to 1 times 2 times 3 times 4 times 5. And so here, and usually I just try to make my life easy. This is 20, this is 6, so 6 times 20 gives me 120, right? So that's what 5 factorial is. This ends up a lot in probability theory, which I'll show in a second. So that's what factorial is. So here, this you may or may not know. So the binomial coefficients come from this. Um, this is often typed in most calculator as NCR. It'll give you this, and this means, and this comes from probability theory. The probability theory is, say I have n objects and I choose r of them, right? So n choose r of them. What's the probability of choosing that number out of all numbers? And so that's where it comes from. Like a bag of marbles, right? Um, and the other one you have is NPR. These are two functions you should see on a calculator. So uh, this means order doesn't matter. This means order does matter. They're two different things, and blah 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 blah. Don't worry too much about it, right? This is the formula we're going to be using for the binomial coefficient, right? These are the same entries of the Pascal's triangle. Okay. Do I know how to type that into Wolfram Alpha is the real question. We'll have to test it. I will test it and we'll see if I can show you how to type in Wolfram Alpha. Okay. So these are the same entries of the r plus 1 row of entry of the Pascal triangle. So you can have n choose 0. And so here is just the formula. It's n factorial. So whatever n is, n factorial minus r factorial, or divided by r factorial, n minus r factorial. So let's do this as simply as, so let's do a couple examples and get you, we'll get you to, so let me zoom on in just because these numbers are a little bit small. All right, so 6. Right, and if I'm zooming in, let me make my thing just a teeny bit sharper. So 6. So this is, I guess I don't need to zoom in that much. Just going to make it better. My thing. So here we're just going to learn how to use what we call define these binomial coefficients, right? So here we'll have 6 factorial over 3 factorial, and then 3 minus, and this is 6 minus 3 factorial, which is really just 6 factorial over 3 factorial times 3 factorial. All right, so if you had to do this by hand, let me explain why this actually ends up being not as terrible as you think. So I have 1 times 2 times 3 times 4 times 5 times 6, right? And then I have 1 times 2 times 3 times 1 times 2 times 3. All right, so this is 6 factorial. So 1 times 2 times 3 times 4 times 5 times 6. 3 factorial is 1 times 2 times 3. And another 3 factorial is 1 times 2 by 3. Well, here, this will just cancel with this. Makes it really easy. 2 times 3 cancels with that. And so what am I left with? 20. Okay. Now, is 20? Let's go to it. 20, if we walk to the 1, 2, 3, 4th, right? Or the r plus 1 entry is also 20, right? And so this is how you can compute stuff for, like, well, say we wanted the 4th entry in the 9th row, right? Or the 5th entry in the 9th row, right? This would be the 5th one in the 9th row. In that case, we'll just compute 9 factorial over 4 factorial over 9 minus 4 is 5 factorial. Notice that these two numbers add up to this number. And so here, if I was going to do this by hand, it's the last one I'll do by hand. Actually, I think I'll do more than one by hand. So here we have 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9. That's good. It gives me room to write down my answer. Here I'll have 1 times 2 times 3 times 4 times 1 times 2 times 3 times 4 times 9. All right, so whatever the larger one is, just go ahead and cross that off the top one. And then here you can kind of get rid of stuff. So here I'll get rid of this and this. And so here I have a 4. I can just make that a 2. So I have 14 times 9. So that'll be 14 minus, or 140 minus 14. So that's equal to 126. Okay. All right. So here, if I wanted to do this, it'd be 100 factorial over 3 factorial, and then 100 minus 3 would be 97 factorial. So this would be 1 times 2 times 3 times 4 dot, 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 times 97 times 98 times 99 times 100, right? Over 1 times 2 times 3 times 1 times 2 dot, 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 96 times 97, right? And here's a dot, 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 right? So this 1 times 2 times 97 will cancel out all this, right? And so I have 6 over whatever this ends up being, and that ends up being, so it's actually not too terrible to calculate. Now here, if I was going to do this over 97, this is 97 factorial over 3 factorial. Well, guess what? That's the same as that, right? These are the same. So that's how you calculate it in here. Let me see if I can type it in. Let me test this real quick. Do I write this as NCR here? I don't know. You probably do. Wahoo! Wahoo! Ta-da! And so we write this as NCR. So N capital CR. I guess I don't know if you need a capital C. Is it smart enough to take the N capital C? Okay, yeah. So here, this is 20. Here we can just type. We can type in what other things we calculate. 9. Oops, 9 and 4. Right. Hi. You get 126, and here we can type in our 103. And so in order to type this in, you type in NCR, okay? So that's the code you'll use in your calculators, and that means N choose R elements, right? And this comes from probability theory. So if I have 30 people so let's say I have 30 people in the class. and I choose 5, right? Um, this is how many ways I can choose 5 people, right? A lot of ways, right? Just a lot of ways of choosing 5 people. Um, and so there's just a whole bunch of different combinations for that. Okay. And an easy way to kind of see this is, and so this is where it comes from. It's from probability theory. I won't get too much into it since we're not doing probability theory in this class. All right, so why do we care? Oh, we're out of time, aren't we? Oops. Give me 2 more minutes and I'll show you what we're doing, okay? We've ended early every day this week, so I'm a little sad to go over on a Friday, though. All right, so here, if we want to find the AR term, we just do this. So here I want to find the term that contains this and this expansion. So here R is equal to 5 in this expansion. So I'll just do 20 over 15. And then here it'd be times 2x to the 5th, right? And then this has to add up to be 20, so this would be 15. You crunch through this using what I shot touch you, and this is 4. This is 4, 9, 6, 28, x to the 5th, y to the 15. Okay. So here, if I wanted to find out what's a particular term in one of the expansions, the term that contains that, you can calculate that. And that's what this is used for. Here we're going to find the 4th term. So the 4th term would be, we're going to let r equal to 3, right? Because here, if you notice, it'd be the r plus 1 term. So if I want the 4th, that means I need to go down by 1. So we let r equal 3 for the 4th term. So I'll have 8 choose 3 times square root of x to the 8 minus 3. And then here it'd be, so 8. Am I doing this backwards? I might be doing this a little backwards in my head. The funny part is if I reverse, this may be reversed. Oh, for the term that contains AR in the expression, it's this. Okay. For the 4th term, yeah, this is correct. This right here is correct. Let me look at this and I'll get back to you on that. This is correct, but here is using a different R for a different reason. Sometimes I don't love what your book does. You crunch through this and you get minus 56x to the 5/2 power, because this would be 5s and this is a half power. So this is x to the 5/2 power, or you could just rewrite this as square root of x to the 5th. Okay, that'd probably be better. And then our 7th term here. So the 7th term here, you're going to let r equal to 6. So it'll be 8 over 6. So our 7th term will have square root of x to 8 minus here 3 or 6, and then it'll be -1 to the 6 because it needs to add up. And this gives us 28x. Okay. So sorry for going a little over. Here, if I want to find the AR where it contains this term, this is the R we're using. Here, if I want to find the n terms of the expansion, I'm technically using a different R, but your book uses R again, which drives me bananas, right? I probably should just write Q and write it all in terms of Q. Let me do that. Let me do that really quick. So here would be uh, n minus Q of AQ of minus Q B Q. And notice since that A of, notice here, because of symmetry, they end up being the same. It really does end up being the same. And so I'm going to write this as Q. Okay. Because A choose, or because of the symmetry of this, right? So if I choose 1 or if I choose 5, it's the same. If I choose 2 and if I choose 4, it's the same. If I choose 3, it's the same. If I choose 0, if I choose 6, it's the same. So because of symmetry, here, if you want to find that term, use this term. If you want to find the nth term, just make Q one lower and do this. Okay? Hopefully that clears it up a little bit. All right, guys. We're